Hello. So this is another exam question, practice exam, not practice exam, but external exam question. External exam. This is from the 2020 external paper two. Paper two, which means you need a calculator. Gasp. So this question is this diagram shows the quadrilateral ABCD. ABCD. It's weird kite-looking shape, no right angles, well, at least from what we can see. Yeah, it's doable. So, determine the perimeter of the quadrilateral. So, when you see perimeter, compared, because sometimes you get area, sometimes you get perimeter, you need to remember units. Units are very important. Units. So the units for a perimeter is just centimeters, because it's just like tape measure around the side of it, you know what I mean? Just the length of the outside. So this is just going to be in centimeters, because these are all in centimeters. Or, it depends. If it's area, it would be in centimeters squared. This isn't an area question, this is perimeter, but if it was area, it would be centimeters squared. But we're not looking for only perimeter, so this is just distance around the outside. So I've already got given 3, but we need this one right here. And from what I can see, there's only really one way to figure that out. So, to start, what we're going to do is we're going to pull out this ruler. I've already lined it up a bit because this is the most tedious thing. Oh, we're randomly zooming it now. It's tedious. Let's line that up. Okay, so what you kind of want to do is because, well, 2 reasons. One of them is that, you don't really see quadrilateral side-by-side solving in the syllabus that much. It's only really triangles. You can split this into a triangle right here, and the reason I do that is because you have 2 full angles here on these sides, and if you just cut a line straight through the center, it would just break these angles. It would be ambiguous. You wouldn't know how to do it. This is much easier because you get these sides and this angle are all in full, and this is the one you want to find because the perimeter is going to equal all the sides, so the sum of sides. So we already have 3. We already have this one, and this one. So now let's get this one here. So the first thing we're going to have to do is let's just cut this in half and find this length here. This length here isn't going to contribute to our final area, but it's going to be used because of our triangle trigonometric ratios. We're going to use this side to turn this into a triangle, and then find this side from here. So the first step is going to be, yeah, just make sure they're all in centimeters, whatnot, you don't know. And also, degrees, knowing that these are degrees. Because if these angles are written as, let's just redraw this, if this is just written as 117, well, it wouldn't be 170, it'd be a smaller number, like 1.17. But if it doesn't have that degree symbol there, it's not degrees, it's radians. And that means you have to transform your calculator, all that jazz. But you know that this is degrees, it has the degree symbol there. Not degrees Celsius. So let's start. So perimeter is going to be in centimeters. I'm just going to rub that out real quick, right there. So it's important to consider units, they're very important. So let's try and find, so this, if we use the normal naming scheme, if you have A as the angle, the opposite side is going to be little a. So let's call this little a. And now we know from the cos rule, which is c squared equals a squared plus b squared minus 2ab cos c. If we rearrange this formula to find a, it's going to be, so we have, but we actually have d here instead, so let's just call this side little d, and let's call this side b, because these are opposite to these angles. So let's sub in these new values and go a squared, which is what we're looking for, equals b squared plus d squared minus 2bd cos a. We have a value for a here, and we have a value for b and d, so let's just sub this in to find a. So that is just going to be, so we'll sub our values in properly, because usually exam questions request you to sub in values properly. So a squared equals 4.1 squared plus 7.6 squared minus 2, 4.1, 7.6 cos 117 degrees. So I'll just jam that all into a calculator real quick. 4.1 squared plus 7.6 squared minus 2, 4.1, 7.6 cos 117. Make sure your calculator is in degrees, because it's a degrees question. And that's going to give you a squared equals, 102.86 centimeters. And now, but because we have the square root here, we need to account for the square root because this is going to be the squared side. So let's take the square root of both sides. You're not going to get a plus or minus answer because even though it's a square root, you can't have a negative distance. It's going to make a equal, and square root of that is going to be 10.14. 10.14. So now that we know this side is going to be 10.14 centimeters. Now that we know that this is 10.14 centimeters, now we have another triangle to work with. So from this, keep in mind we have two known sides and one unknown angle. And from this, you know that these match up. These match up because they're opposites, C and A, but A could also be called little c because it's opposite to C as well, you see? So this can be C and C. So with C and C, we could also find this angle here, because with our trigonometric ratios, this is going to be, once again, this is going to be little d, but let's call this D2. So this is going to be D2 here, and this is going to be our C and C. So with this, let's use our trigonometric ratios of sine rule, and find this angle here. Find this angle for D. So, and the reason we want to do that is because we aren't able to immediately find this side here. So, to be able to find this side here, we need this angle, because then we can do another trigonometric ratio and find this one. And the way we do that is we're going to find this angle, and then we know that in a triangle, all the sum of angles is 180, so we can go 180 minus known angles to get the final one, to get the final angle, and then we can use our sine rule again to find this side. So let's just do that. So now that A is 10.14, I mean. You can also round it to keep your significant figures, but in math we don't really need to do that. So now let's do this. So it's going to be, so let's just write the sine rule formula. Sine A over A equals sine B for B, but we don't have A and B, we're using, so our knowns are going to be big C and little c. So sine C over little c equals sine D, capital D, which is our unknown, over little d. So let's sub these values in. So sine 62 degrees over, and then C, which is we found earlier, because A is equal to C, which is 10.14, equals sine D, our unknown, divided by, and then side D, which is 5.4 centimeters. You can, let's move this up here. Let's just corner this off. So sine D, if we rearrange the equation, is going to be equal to 5.4 sine 62 degrees divided by 10.14, which is going to be equal to, put that in my calculator, so 5.4 sine 62 divided by 10.14, which is 0.47, 4701. And now with this, we can take, because this is sine of D, we can take sine of -1 of this, sine -1 of this, and then we'll end up with the angle D. So D equals sine -1 of that answer, which is 28 degrees. So let's write 28 down here, 28 degrees, and now we know that the 180, so what's our unknown angle here? Our unknown angle, let's just call it B2, capital B2. So this is going to be it. So that unknown angle there, 180 equals B2 plus 28 degrees plus 62 degrees? Yep, 62. So you need to remember this rule, that all the sum of all angles in a triangle are 180, and because we have one unknown angle, we can find that. So let's just, 180 minus 28 minus 62 is going to give you 90 degrees. B2 equals 90 degrees. That's funny because I said at the start that I couldn't see any 90 degree angles. That's coincidental. So it's going to be 90 degrees here actually. 90 degrees. And now that we know that, 90 degrees, we can once again use our trig ratios, our sine rule. If I erase this here, we can once again use our sine rule. Because we have two sides that are known, let's just use D2 and capital D. So we can use these angles, and we can use this angle to find this unknown. So this is going to be, I'm just going to write it up here, sine, wait, no, so we're going to put the length on top now because we need a length. So this is going to be little b2. b2 over sine b, capital B2 is equal to d2 over sine of capital D. Now let's write that down here in our working out. Oh, what just happened? Yep, I love this app. Okay, so now we have 90 degrees. We can use what we wrote up here. b2 over sine b2 is equal to d2 over sine d2. Sub in our angles. So we know that our b2 is going to be our unknown. So b2 over sine 90 degrees, which is the angle we just found, equals, 5.4 degree, 5.4 over, and then sine d2, which is 28 degrees, which we found earlier. Sine of 28 degrees. If we rearrange this and solve, I'm not going to show the step of rearranging because we're running out of space, but that would be 5.4 times, we just cross multiply and divide, so 5.4 times sine 90 divided by sine 28, which is equal to 11.5. Now, you have to realize we're not done yet. We've found all the sides, so this is 11.5 centimeters. And now we need to know that you would finish this on your working paper, but I'm going to do it out the side because I don't want to import that. So we know that perimeter equals the sum of all sides. So let's just call it big P is equal to 11.5 plus, and that's all around the outside of the shape. We're not going to use this inner line that we found because it's not the perimeter of the shape. 11.5 plus 5.4, so 11.5 plus 5.4 plus 4.1 plus 7.6. 1 plus 7.6, which is going to be equal to 11.5 plus 5.4 plus 4.1 plus 7.6. 28.6. And remember, these are all in centimeters, because that's a straight distance around the perimeter of the shape. 28.6 centimeters. That is the answer. Thank you for watching.